The y-intercept is where x equals 0. And the x-intercept is where y equals 0. Now, why does that matter? Because today, I not only need you to know this lead term and all the stuff it does, and that's what we did for the last couple of days, but I also need you to know the x and the y-intercepts of the graph. Because today is where we actually start graphing them. And you know what the test on this is called? Graphing. So up until now, we were just like trying to know what the end of the graph does and the beginning of the graph does. But now we actually start doing the whole graph. And I'm going to say this one more time, and let's see if in your head you know what to say. If I needed the x-intercept, I would put y equal to 0. If you don't have a good enough short-term memory to remember that, maybe you should write that down. The x-intercept, you make the y 0. And if you wanted the y-intercept, you'd make x equal 0. Do you get if I make x equal 0, there'd be a 0 here, and here, and here, and then everything knocks out except y equals -4. Now be careful. Some of you are going to start saying, oh, so you're saying the number on the end is the y-intercept. Nope. It's not always the number on the end. What I did say is the y-intercept is where x equals 0. And in this case, yeah, it's the number on the end. But what if it was like this? The y-intercept is where x equals 0. You put a 0, you put a 0, and then you get 3 times -1, which is -3. It's not the number on the end. You get what I'm saying? It's not always the number on the end. The y-intercept is where you put in x equals 0. And the x-intercept is where you put in... Somebody say it. Come on. The x-intercept is where you put in y equals 0. So let me show you what that looks like. If I put in y equals 0, do you get I want the whole thing to be 0? So then like I go, oh, so you mean this part needs to be 0? And this part needs to be 0. And you solve those little bite-sized equations, super easy equations. All right. So we got to remember where the x and the y-intercepts come from. The x-intercept comes from y equals 0. And the y-intercept comes from sticking x equals 0 in. So if you want the y-intercept, stick in x equals 0. If you want the x-intercept, stick in y equals 0 and figure out what makes each part 0. All right, now, that's a reminder of stuff you did learn before. I know you learned it before, but whether you had it in your head before now is a different question. Now, here's a question. This one's way trickier. What's the x-intercepts? I tried to pound it into your brain, but it might not have worked. The x-intercept is where what? The x-intercept is where what? No one has a short-term memory? The x-intercept is where what? Where y equals 0. Maybe you should write that down. I just did. You should write it down too, because nobody's answering. That means nobody knew it. Or some of you are just too stubborn to say it out loud.
Wouldn't want to look that uncool to answer the teacher's question.
All right, the x-intercept is where y is 0. So then, I guess he's saying to put a 0 here. And then, I guess, -2x minus 3 needs to equal 0. And x plus 4 needs to equal 0. And you solve those little two tiny equations and you'll have your x-intercepts. Do it. Do it. Solve those two little bite-sized equations. In a second, I'm going to ask you to compare with the kid next to you. And if you say, I just don't know, then they're supposed to show you how. This was on your last couple tests. You've been practicing this forever. It's supposed to be easy to find out. All right, to a reminder who you're sharing with, you two are comparing, you two are comparing, you three are comparing, and you three are comparing answers with each other. There's two answers for this. X equals this and x equals that. These two rows is super easy. It's just the person across from you. Kid in the back, you're gonna compare with the people in front of you. You three compare, and you three today. Okay, talk to them.
But I just had to divide the negative 2 out. And then get negative 6.
Plus 3. So this one would be negative 2x, because these canceled, equals 3. Divide by negative 2, divide by negative 2. And if you're like concerned about where you would graph negative 3 over 2, did you guys know that 3 over 2 is like 1.5? And when you're graphing today, just put it about where 1.5 would be. Today is not super accurate. So if you get confused on this, just know that it's about 1.5. So you go to where negative 1.5 is, put a dot. All right, how about this other one? Well, that one was super easy. Minus 4x equals negative 4. What were those things called again? Well, they were x-intercepts. So on the graph, this is what they look like. There's a dot here and a dot here, you know, and in this case, I guess we had negative 1.5. Okay, well, that should probably be pretty close to 0. So negative 1.5 might be like right there. And the other one was at negative 4. Oh, okay. That's must be more like over here. Now, if I told you that those are the two spots that this graph hits the x-axis, as in they're the x-intercepts, and I told you that this graph was going down on the right and down on the left, then wouldn't you be able to like figure out it looked like that? So how on earth would you tell it was going down on the right or left? From the lead term. This is what we did all yesterday. You take this and put it to a power of 1, which doesn't really do anything. You take this and put it to a power of 1, which doesn't really do anything. And then you multiply them, and you get negative 2x squared. And that told you a ton. As soon as you know that lead term right here, you remember this deal where that tells me it's going down on the right, and this is even, so that means that it's the same on the other side. So it's down on the right and down on the other side because it has to be the same. That's how I knew that this graph would be going down and down. Yes?
Do you guys mind go back to the lead integer? So what would happen if it was a positive instead of negative?
Well, then the whole graph wouldn't be negative. Like if that was not negative, that would be positive, right?
Yeah.
And if it was positive, then it's going up on the right. So the graph would be totally different. It would be going up here, and since it's the same on both sides, it'd be going up here, and then the graph would have gone like that.
Oh. Yeah.
Good question. All right, next, not such hard math. This is like easy math. Draw an x and y axis. I'm going to put a few dots on there, and we're going to play connect the dots. Seriously, because that's what this comes down to. Once you're good at finding the x-intercepts and the y-intercepts, you just have to connect the dots in a logical way. But it's not like the old days where you'd connect the dots and it's like, oh, it formed a square or something. This is a little more complicated. All right, so please make a dot here, and a dot here. And if I tell you it's going down on both ends, can you make what the graph would have to look like? Connect the dots. Because see, that's a kid who has found the x-intercepts, found the y-intercept, and he knows it's going down on both ends. I think that these are pretty easy from here. Can you connect the dots and make a little puzzle? Well, it's got to be going down on this end, so I'm going to go up like that. And that's got to be going down on that end, so I'm going to go like that. And I just have to go up and like something like that. That would go through all the dots, and I would have given it credit. Could it be slightly different? Yeah, I'll do it in like blue and show you. Kid could have gone like up higher here. That would have been okay too. It just goes through all the dots. All right. Ready? Another connect the dots. This time, it's going up on this end. Goes through this. Goes through this y-intercept. Goes through this. And this. And it goes down on that end. Could you have found the x-intercepts? The little things that are in the little parentheses? Yeah. You could have found the y-intercept from setting x equal to 0. And then you'd have all this info. Can you finish the deal? You know what the line looks like? In my opinion, the easiest way is to just start on one end and then just kind of flow with it. It has to go like that, right? Then I have to go through there. I have to go through there. And I have to end going up. And there we go. That's called a polynomial. And that's not a perfect graph because we don't have like 1,000 points. If we'd have found a whole bunch of points, we would have been even easier. But we had the x-intercepts, we had the y-intercepts, and we knew it was going up or down on the ends. All right, one more. It's going through that, that, and that. It's going down on this end and up on this end. And I don't even have to tell you the y-intercept, and you could do it. Sometimes you don't even need the y-intercept. Start on one end and just flow through the points. Nice smooth line. Like that, and then that, and then that. See how that makes sense? Goes through all the dots. Goes down on one end and up on the other. All right. So, I almost never say this, but I usually give you a one time in class where you can just watch. Don't write this down. I think it'll take you too much time. I can write it down and do it for you, just to show you. Here's how I'd do them. Every single time I would start by figuring out that lead term. It's a big deal. That's all you did on the homework yesterday is find the lead term. X to the 1, x to the 1, and x to the 1. And there's a negative to also. So it's negative x to the third. Do you get how we did that yesterday? Do you get, now I know which way the graph is going. See, since I know that this is negative, I know it's going down on the right end. Since this is odd, they must be going opposite directions. So it's down on the right end, and they have to be going opposite directions. It must be up on the left end. And then I know it goes through -4. Remember that deal? You want this to equal 0, right? Because if y is equal to 0, you're finding the x-intercepts. So this would be -4. And that's like over here somewhere. This is at 3, which is like maybe over here somewhere. And this is at -3. That's what'll make this part 0. So here's where -3 is. And if I know that it's going down on this end and up on that end, sketch it. From there, you should be able to sketch it. Just do that thing we just did. You go, okay. Well, I guess it has to go through here. And then there. And then it has to be going up at the end, so like that. Think you could do that? And that's the homework for today, is like that. All right. Now, one thing that stumped a whole bunch of people is as soon as I threw in a 2 right there, calamity for some kids. They're like, I don't know what to do with that. I mean, I know this one's -5. I know this one's 8, but I don't know what that one is. Is it some kind of fraction? Yes. So here's what you do. You go 2x minus 3 needs to equal 0. Because if we're doing this, it's because y was 0, and we want to find what makes this 0, what makes that 0, what makes that 0. And sure, these are easy in your head. But this, you have to write the equation. Would you please solve that one? And it'll be a decimal. And then don't freak out that you have to graph this decimal. I'm not going to be asking for perfect accuracy to the decimal point. But solve that. It's a fraction. So obviously 2 of the answers are 8 and -5, but what's the third one? Some fraction. Would you please compare with the kid next to you and see what fraction they have? You guys did 3/2? If you didn't know that that was 1.5, you could go 3 divided by 2 and it would tell you 1.5. So that's about 1.5. So if I had to graph this, now I'd go, and here's where 1.5 is. That's what I'm saying 1.5 is. You know, I don't need it to be super accurate, but I better put it on the positive side at least. And then let's say this is 8. We'll say this is 1.5, and we'll say this is -5. But how do I know how it goes up and down? Because of the lead term. 2x to the 1, x to the 1, and x to the 1 would make 2x to the 1, 2, 3. 2x to the third. That lead term is huge because it tells you both ends. It tells you the degree. It tells you like so many things. You got to find the lead term. So since this is positive, it must be going up on the right. Since that's odd, it must be going the other way on the other end. And from there, it's just a game of connect the dots. That make sense to you? All right. So we only have 6 homework problems. In my continuing effort to try to make your life reasonable, I think 5 would be just as good as 6. So please cross off the last one, skip number 6. Get that homework downloaded. I will do number 1 with you, because I always feel like once you're started, you're halfway done. And then all you'll have to do is problems 2, 3, 4, and 5. So you literally have 4 homework problems after you do 1 with me. It's doable. So do it. Homework makes more grades change than anybody would think. They would think, your homework's pretty much doesn't matter. Your tests are worth so much more. Total lie. Let's say the kid's name is Adrian. If I pick any one of you, right now, nobody has 100%. 0 kids have 100%. Almost all of you have a percent that's like somewhere near the next grade. Let's say that Adrian's got 91.5%. Do you get that Adrian is only 1% away from a straight A, which is a 92.5? If you're only 1% away, which almost all of you are, you're either 1% away from the grade above you, or what if it's Bobby is at a 80.3? Do you get if he drops 1%, he's going to be at a C plus instead of a B minus? Almost everybody in here is 1% away from either dropping out of the grade they have and going down a notch, or you're 1% away from going up. Almost everybody. I did the math on it once, and it was like 80% of kids are only 1% away from either the grade above or the grade below them. Do you get 1 homework assignment at this point? Moves you a whole percent. Don't turn in 1 homework assignment. Your grade will be 1% lower than it was. There you go. You just lost your B minus, and now you're at a C plus. So don't tell me homework doesn't matter. Totally matters. People get it twisted because the tests are worth more. That's true. But homework assignments, just 1 missing. You just lost the grade you had. Or do enough of them, and it actually can raise your grade that percent. All right. Enough said about homework. Just do your homework. Number 1. Marcel, would you read me problem 1?
Y equals, in parentheses, x plus 1, in parentheses, x minus 3, and in another parentheses, x plus 5.
Perfect. And all we have to do is graph this thing. But did anybody remember that right away we should get that lead term? I'm telling you, every single problem on your test, you should stop and go, do I know what the lead term is? Because that tells you so much. tells you how it ends on the right, tells you how it goes on the left, tells you the degree, tells you the lead coefficient, tells you so many things. It's x to the third. Just added a page by accident. There we go. So now I know how it ends. Since it's positive, it's going up on this end. Since it's odd, it has to be going down on this end. Now, it doesn't even say to find the y-intercept. You'll find that you don't often even need to figure it out. If I needed the y-intercept, I would put in x equals 0 and 0 and 0, and then I go 1 times negative 3 times 5, which would be negative 15. But I don't need it, but now you know that's what it is. Negative 15. You don't have to have that sometimes. The directions on the test will tell you, must have correct y-intercept, or sometimes they don't have to have the y-intercept. But what they have to have for sure is that negative 1 is one of your x-intercepts, 3 is one of your x-intercepts, and negative 5 for this one. Negative 5 is one of your x-intercepts. And can you make it go up from there through this? Well, I already know that one's going down there. And then it must go like that. There we go. Boom. Done. That's number 1. All right. You guys do number 2. Again, some kids freaked out last hour because there's a decimal in it. I just want to start number 2. Yes?
Why is, I'm sorry, I wasn't listening. Why
That's
is
all right.
X down?
All right. Because, first of all, we start with the right side. I know that's not what you're asking, but start with the right side and go, why is that up? Because this is positive in front. It's up. Then this odd number here tells me that the ends have to be different than each other. So since this one's up, then this one has to be different. That's why it's down. Because when the degree is odd, both ends will go opposite ways. Okay? So when this is odd, the ends will have to be going opposites. And I knew this one was up, so the other one had to be down.
How did you know that one was low?
How is that one up? Because this is positive in front. If that had been negative, then it would have been down. Okay? So the number in the front, right there, that tells you if the right side is going up or down. This tells you the right side. This tells you whether it's the same or different as that. I'm glad you asked. All right. Number 2, I just wanted to start it. Sam Lowe, would you just read me the problem, please?
In parentheses, x minus 5, then in parentheses, x plus 3, and then another one, x minus 2.
Oh, crap. This isn't the one that people had trouble with then. Yeah, it's number 3. Okay, so number 2 is going to be pretty easy. You guys know the lead term on this would be x to the third again. So it's another one where it's up on the right, because that's positive, and they go different directions. All right, let's go down to number 3. Sam, would you read me 3?
In parentheses, minus 2x plus 3, and then in parentheses again, x plus 1, and then another parentheses, x plus 6, and then in parentheses, x minus 4.
Holy cow. All right, well, most of these are easy, right? This one's going to give me a 4x intercept. This one's going to give me a negative 6x intercept. It's whatever makes it equal 0. So this is the weird one. So write negative 2x plus 3 needs to equal 0, and then just solve it. If you can't solve a 2-step equation like this, we better fix that, because that's going to happen in Algebra 2. It's going to happen all the time. And yeah, it's a fraction at the end. Or then you can change those to decimals with a calculator. That's fine. So if I was graphing it, some of these are easy to graph. Like I know where 4 is, duh. I know where negative 6 is, duh. And if it's a decimal, just put it about where you think it is. Don't forget this one. And whatever this comes out to, that's your job. You figure that out. You can always ask the kid next to you. It's a fraction. All right, that's all I got for you for today. Whoa.